With that, let's close out with why James Webb Space Telescope even needs fuel once it gets to this Lagrange point, right? Everyone talks about L2. I think it's Lagrange points are often talked about as like a single point, almost as if the James Webb Space Telescope is going out there and then it's just sitting still in space, not moving, which if you're talking about in space, you've got to ask not moving relative to what is always the question you've got to ask. Okay, it's not moving. Well, if I look at the Earth from a certain vantage point, the Earth isn't going to move, but that's because you're probably moving with the Earth so that you're both moving the same speed, which makes it look like it's not moving. But that's just a physics and like a 3D space phenomenon. But with James Webb Space Telescope, it's not just sitting at L2. And I tried to take what's visible already. We'll put a graphic of this up right now, but I tried to take a visual representation of what that means. And so you've got the sun, right? It has its own gravitational forces. It's pulling on things around it. It's manipulating space and time around it, right? Earth is orbiting around the sun because it's in its gravitational influence. And as what we're looking for L2 Lagrange points are these pockets of gravitational pull where the balance between the two things pulling is just the centrifugal force, so just the orbit. So when we say L2 and we say it's the Lagrange point 2, it's not a point that's sitting at rest. It's a point on the moving thing. So you've got, let's see. I don't have it ready, but okay. So here's the sun and the Earth's orbiting, right? So we want to put James Webb Space Telescope at L2, which is the point behind Earth and the sun. So you've got the sun, the Earth, and then you've got James Webb Space Telescope in that pocket. The sun and the Earth are pulling against each other, and behind Earth, about 1 million miles away, as it's orbiting, is a great point for you to put James Webb Space Telescope as the Earth orbits the sun. So as the telescope is behind the Earth all the time, it's protected a lot from the sun because you've got Earth blocking a lot of that heat, which means we could put up those shields behind the James Webb Space Telescope, and now you don't have the brightness of the sun getting in the way of the telescope, so you've got James Webb Space Telescope always behind the Earth, which is behind the sun, giving this great dark view for the telescope to look back into the early, well, to whatever it wants in the universe, right? So Lagrange points are these pockets where the gravitational pull is minimal, almost zero in certain cases. At that point, ideally, it would be zero. And so James Webb Space Telescope is doing this halo orbit in that area. And so what that provides is a really low-cost way to have your spacecraft be in space and be in a relatively easy position where you don't need to spend a ton of fuel, reorienting it and getting it to go in the right spot. It's just going to kind of keep doing tiny bursts to keep it in that halo orbit within that pocket. I don't know if that's any easier than calling it a point. I don't know if my explanation was any better, but I hope that explains it a little bit better. And we do have that visual and some other visuals from NASA to help explain that a little bit better. It's an advantageous position to put a spacecraft that you want to be in a good-looking position deep into space without any sunlight. So, and actually, I could pull up NASA's explanation. That actually might be better. So Lagrange points, according to NASA, are positions in space where the gravitational forces of a two-body system, like the Sun and the Earth, produce enhanced regions of attraction and repulsion. These can be used by spacecraft to reduce fuel consumption needed to remain in position. So again, going back to the whole thing about space and why it's so hard, you only have the fuel that you bring with you. So you need to budget out all of your moves ahead of time and bring enough fuel for that. And that's the magic of what James Webb Space Telescope did is it saved so much fuel by doing orbital mechanics so efficiently that we were able to have more fuel to keep up this L2 halo orbit for years. So talking about fuel efficiency, that is a beautiful, beautiful thing that the James Webb Space Telescope did to keep this mission going. So you're getting even more out of the money that we invested into this, right? Which was a lot of money, and time, as we know. So these Lagrange points between this two-body system, think about it. If there was a three-body system, right, that you were considering, you would have different Lagrange points. It would have a different pattern to the gravitational pull and attraction and repulsion that's going on. And when those balance, those pockets are where you want to put things that need to stay in place or in a certain orbit without a lot of fuel moves. So this brings us to our closeout, folks. James Webb Space Telescope has gone on its way. That chapter of getting it to launch is over, and we move on to the next chapter where it's actually going to start doing its observations. And it's doing it in infrared light, which is going to be very different from Hubble. But we're going to see some really amazing things, and we're going to dive more into this, and we hope that you guys send in your questions. We'd love to hear from you. What is it that you want to learn? This Lagrange point depiction that we're talking about here, this is a question from you guys. This is things that you guys reached out and said, hey, can we talk about that more? A lot of, it doesn't really make sense. What more could we talk about? And we appreciate every time that you send those questions. So you can reach out to us on Today in Space Pod on Instagram and Twitter. We've got todayinspacepodcast@gmail.com for any of your questions. And, of course, Today in Space on TikTok. And we're also on Substack at todayinspace.substack.com. We're going to be using that more often to dive deeper into some of these topics. But that's it, folks. Thanks for joining us. We really hope you have a good rest of your year, the last few hours here of 2021. Write them off. Look forward to the future, and we wish you nothing but the best in this next year. We hope it's sizably better than 2021 and incredibly galactically better than 2020. So we wish you nothing but the best.